All right. Well, good evening, and thank you for staying on. And I want to do a talk tonight on 3D printing. And unlike a lot of my talks that tend to get into the weeds, I'm going to do my very best not to do that because the topic may be of interest to many of you and others not. But I thought that it would be helpful to share a little bit about my introduction into 3D printing and what I was able to, what I have been able to do with it. And we'll have a little bit of a demo here as well as we go along. Um, like I said, I normally are on top of things, and I guess if you got to ask yourself the question, gee, is it really helpful for a ham to have a 3D printer? Well, probably the answer is no. I mean, it was always helpful, but is it essential? You know, is it essential? Probably not. I did not have a 3D printer for a long time. My son, in fact, when he was 12, and he's quite a bit older than that now, first brought that concept to me. He says, yeah, they got this thing called a 3D printer. And it was pretty interesting. And he showed me what it could do. And this was a kit and all that good stuff. And I normally like to jump on new stuff like that. And it was interesting, but I couldn't really find a use for it. And really had not for some time. In the years that went by, the prices of the units have come down substantially, and you can make them yourself. So they kind of got to be a little more attractive. And that kind of gelled around the same time when I was doing a lot more electronic projects that I really wanted to put into some enclosures. And it's difficult. No, not difficult. It's not that easy to find an enclosure that actually meets the need of your project. You more or less have to kind of make things do. And I thought that would be a good way to get involved in it. So when I got an Amazon gift card and a few other things like that, I decided to pull the trigger a couple of years ago, and I got a Creality Ender 3, which is kind of a low end, but okay 3D printer. So that is where I'm coming from here. And tonight I'll just show you a little bit about how the process works for those that are not familiar with it. And I know that some of you are probably substantially more experienced than I am in this area. And I do know for a fact that there's some people here that are heads and heels above me when it comes to 3D modeling, which is something that is basically being able to take a shape, whatever that might be, and make it into a form that can be 3D printed. I have done that, but I am definitely not in the major leagues in that area just yet. So let me turn over to show you, not this. Okay, this is my 3D printer. This is not the Ender 3. This is actually a Prusa MK3 Plus, which I upgraded to. Let me pull back a little bit on there. You see a little bit what that looks like. And that is a pretty typical FDM printer, which is, I think it's like fusion disposition model, fancy acronym. Basically, they take hot filament and fuse it to the thing underneath it. There are many kinds of different 3D printers, actually, different types of 3D printers. These are the ones of the style that I first told you about that my son was mentioning. But there are other printers, specialty printers. There's resin printers for creating a very detailed models, usually on a much smaller build surface at this point in time. They tend to use toxic chemicals, and I just really don't want to deal with that. And there are varying other forms of printers that can print metal and wood and carbon fiber in a massive scale. That's pretty cool as well. There's actually, you probably might have even seen it in the news recently, where they had 3D printing of houses. And that particular type of printer is a 3D printer, and I guess it's technically a fusible thing. You're fusing concrete on concrete, but it actually goes, and instead of heating the filament, that will go ahead and just basically extrude concrete through the through the nozzle, and then it goes back and forth in a mechanism and actually be able to print a house, to make a house in large statues and things along those lines. So that's pretty cool. But that's not what we're doing here. We're definitely going a little bit more modest. Switch over here. I have this set up so that I can actually control my printer by turning it on manually and controlling it. Over here, here is a SD card that contains the file to be printed. So that works just fine. We can just put that right in there. If I print off of a card, it's kind of nice because there's some protection against a power outage, because there's nothing worse than printing something that takes hours or maybe tens of hours, and then you find out that you lose power. So what that will do, if you print off the card, it remembers where it was at, and you can mostly recover and sometimes completely recover from a power failure. But what I normally do is I actually use a program called Octoprint, which is running on a Raspberry Pi. I should probably point that out while I'm here too. The Raspberry Pi is located here in the back of the printer along the side. And there's also a camera here. These are things that I added onto it in addition to the stock printer. So that allows me to kind of send models out there, check the status of the print, and do all kinds of stuff without having to go and have to fiddle with the SD card. So right now I'll go ahead and I'll command the printer to turn on, and there we go. I'll show you Octopi in just a second, but I did want to kind of explain a little bit how this works. This is very much like a CNC machine in a way, in that you have an X and a Y and a Z axis. The difference between a CNC machine is that they tend to be, oh my goodness, here, subtractive devices. In other words, so you'll have a block of material, and then you will be able to, carve away or remove that material. 3D printing is an additive method. Basically, we have a flat surface, and then we kind of build things up. But otherwise, they're very similar in concept. I'm going to switch to control here. Oops, I don't want to do that. There we are. And I want to show you how this works, and then we'll get into. I have a screen within the screen within the screen. So what we could do is with 3D printing, we have the ability to move in the x-axis, as you're seeing here. And it's very precise as well. We're talking tenths of a millimeter of movement on that. So that's not too bad. So we can go in the X, we can go in the Y, and there's a home mechanism. And then the final thing is in the Z-axis, which is up and down. So, and when we start a print, you'll see this a little bit more. The other thing about this is that what you're seeing right here, there are stepper motors here and here and behind here that control that. There's also a stepper motor here, and that is for the feeding the filament. This is filament. This is one of several types of plastic, which we can talk a little bit about later. But basically, it feeds into here, and then underneath the head over here, you can't see it very well, but there's an extruder. It's basically a metal nozzle, and there's a heating element here. And what happens is that when we start to print, this is the print bed, and that print bed will warm up. It doesn't have to, but for many filaments, but it warms up, and that helps the plastic to adhere to the bed, because you don't want, once you start printing something, you want to have it stick to the bed until it's done. So this helps over here. And then this is another fan which helps cool the filament as it goes out, so that you just have to kind of get the right ratio of heat and cooling for the optimum print. But in truth of matter, if you're printing with something called PLA, which is a very common filament, it's a great filament to start with, because it allows us to it's pretty forgiving on printing and temperature ranges, and it's a really, really nice material to work with. Let's see, I'm going to turn over here. I'll get back to that later, and we'll go back here. So what do we do with that? Well, the first things that I started printing were cabinet for enclosures, as I mentioned. So I have a lot of different ones. I'll just show you some of the ones I've printed and printed in the past. Here's one for a piece of test equipment. There's a cutout here for the a 16 by 4 by 16 LCD unit. And the beauty of it is everything fits perfectly. And I cannot stress that enough. If you got a good model and you laid things out, it will print. This is another thing that I printed for one of my QRP rigs. And all of these items in here, I laid them out and went to go and print. And in a few hours, or not, this is about 2 hours, that one just printed just fine. And it's pretty nice. So let me see if I can bring up the model that I did for this. And probably before I should do that, I should see if I can share this screen. And if I can fit the right one. Okay, that's my slicer. That's nice, but I really want my oh, here it is, Chrome. I wonder why that's not displaying. Okay. It's just another example of how everything works fine until it's not. So hold on, if you'll just give me a moment, I'm gonna remove this and add this. And that's not what I want to capture. What? I think what happens is when I switch over there, I lose something there. Okay, well, we won't need to really get into that a lot. And I can demonstrate this in another way. Whenever you want to print something, basically you need a model. And that is typically a file, and there's many files that are freely available on the internet. One of the most well-known ones is a site called Thingiverse. And if you go to that, it's thingy, like thing with an I and a verse, thingiverse.com. And it'll show you thousands of models that are available for that, and they're all free. And then you can search for amateur radio. And I was going to show you what I have here on my screen. Anyway, there's a number of models for mounts for radios, chassis, customizable antennas, a Morse code machine, and things along those lines. So that's where most of us get started with the printing. And that kind of takes you quite a ways. I mean, it got me quite a bit further, because normally if there's something like, if I had let's say I have an Arduino and I wanted to have a cover for that for a code project I'm working on, well, you can go down and freely download those models and get them running on your system. And it's very helpful. Oh, I should probably actually do this. Sorry for subjecting you to that. That is a very, very good start. And once you have that, then you can load that model into a program called a slicer, and won't go deep into the woods with you. But basically, the idea is that once you have a model, you need to be able to go ahead and prepare it for printing on the 3D printer. And let's see, and find this one here. Copy. These are called STL files. And there's an example of a plate, back plate of that radio that I built. In fact, I think I'm going to do a different one here. Take this and show you a battery compartment. Where did that go? Oh yeah, here it is. Here's one for a case for one of those buck boost converters that you can get on Amazon. And this is another model that you can get directly from the internet. Let's see. So the idea is you load the model up like we did here, and then it has to be what we call sliced. And what that means, this model right here is is constructed by a series of triangles and geometric triangles, and that doesn't really work so well. So what you want to do is be able to have a program that will, if you can imagine like a meat slicer that will go in and cut those down into sizes, and then each of those sizes will be output to the printer one layer at a time, and then you'll be able to realize your model. Let's see here. So what I'm going to do is I'm going to show you an example of that. Here's the model that is on the screen right here, and this is a situation where we have the base of the unit right here, and then the top of it over here, and then they have a couple of buttons. These are somewhat flexible push buttons to be able to do that. So once we have this, I'm going to actually go ahead and slice this model, and I'll show you what that looks like. Just takes just not very long to do it all. This particular model. The other thing I want to say too is 3D printing is not a speedy process. Typically, it only prints about now it varies, but let's just say just a couple of inches, maybe an inch to maybe 2-3 inches a second. And remember that each layer is about 2.2 millimeters typically. So there's a lot of area to cover as it builds up. So it does take time. This particular model here, if I was going to print this, would take 2 hours and 7 minutes to print. So again, you know, you kind of got to get it in it for the long run. And let's see. I should hit my other control in here. Okay, here we are. Back to my camera. Not that, my other camera. So what you can do then is once you slice this and output it to the printer, it will come off, and you then can fit your pieces. And some of the things that I printed with that, because you got to have a reason for that. Like I said, one of the first things was plastic enclosures, a front panel for a QRP rig, and simple little things like this. Like this is a VESA thing for the back of a television set that a Raspberry Pi can mount on, so I can mount a Pi there and back to the TV set. And something that also is handy is this is a power pole expander that I printed. I didn't print the power poles, but I printed the case and how that all mounted up, which has come in very handy. Other things having to do that is a power pole. Again, this is another power pole. You probably see these online. You can purchase those. Here's this one that has printed the actually container as well as the nut. And it's nice because this is actually a locking mechanism. I'm sure you're not going to, oh yeah, you can see that there. There's actually a hole there. I gotta get on the right side here. That's a hole right over here, which you can put the anchor pin. All of this stuff was all printed and came off of the printer in one fell swoop. And this took about an hour to print. I also have a library of common objects that I can use to lay out my own panels. So I might have a one for a volume control. Obviously, as I mentioned before, one for the liquid crystal display, potentiometers and things like this. And you can even actually make them so that they kind of lock in place, because you can just actually fits in there in that groove, and it doesn't rotate. So I have a library, and one of the other libraries is for a power pole. This is also holds a single power pole. This is a panel mount, and this is a standalone one, so I can retrofit something that I already have if I want to do that. Or sometimes I can just as well actually build that into the box itself as part of the units. This is a prototype case for the Pixie that Joe and Pierre and I and others built. So that was pretty cool. And here's another situation where I had a project, and this is actually a good example of a model that I had downloaded, which actually only consisted part of this, just that speaker portion there. But what I wanted to do is I not only wanted to mount a speaker, but I wanted to mount some electronics underneath the speaker, so that this actually became, this is one of my wireless caller ID stations that I came in there. So I was able to take this basic model, which just consisted of the top portion, and through a modeling tool, in this case, I wimped out and I used something called Tinkercad, which is a very easy to use and very basic, but still useful for beginners to use to be able to do that. If I had some real chops, I would learn how to use Fusion from AutoCAD, which is you can construct anything with that in there, but it is a little bit of a higher learning process. One thing you can print. Here's an example of a lead. Bolt this to the wall, and you can hang your test clips on there. Let's see. General purpose tools. These help me sort out my metrics in particular. And this is universe there, right here. So you can actually tell your size and then also the length. I mean, you can see, you can get these in the store, but it's fun to make them yourself. So there's a lot of little things. I won't get into them all. One of the things that I enjoyed printing are these desk plates, these customized desk plates. This is one we made for the scouting event back in 2020. So these were at each of our stations over there. Here's one that I made just for my desk. You can't see it's white on white, but it's basically same thing, but smaller. That one took about 2 hours to print, and this one actually, well, this one took probably about 9 hours. Some of the ones, like if you like WB on ICF, if I would make that in this size, I'd be looking at about a 12-hour print. But it is fun. Sometimes your prints don't go well, and this is what you end up with. You get something that just looked bad. And actually, this got a haircut. 3D prints that always don't go well. They generally do, but you do have to be careful. And this one I had complete confidence was going to be working just fine. This is actually printed with a wood filament, say basically a PLA, and it has wood grains put into it. And it feels like wood, it sands like wood, it takes stain and paints like wood, and it's pretty cool. So this was supposed to be a Groot for my daughter, and I had it set up, and I was probably a good 4 hours into the print, and I said, I'm going to go to bed. And then I woke up the next day, and instead of expecting to see the nice finished Groot in there, it had basically Cousin It. This was what they call a spaghetti type of thing in here, and what happens is that if the hot end, the area where the filament is being deposited, if that for some reason does not adhere to the model, then it kind of gets lost and it starts printing in air. And it took me a while to figure out what was wrong with this. I did not understand why that would happen, because I had it solidly attached to the the bed, and everything was going well. And I woke up and expecting to see a Groot, and I saw Cousin Ed, as I said. And actually, it was kind of interesting to find out. If you take a look, most of these models that we print are not solid. You can print them solid, completely solid, but it's just a terrible waste of filament. So what we do is we have something called infill, and those are patterns that kind of add structural integrity to your model. This is very rigid. And the particular one that I used here is kind of a pretty gyroidal pattern in there, which actually causes the bed to move a lot during the printing process. And that's not normally a problem, but in some kinds of models like this one right here, there was a head and it needed some support. Even you can even see here, like with the arm, printers can't print in the air, so they had to actually put some support material in there. And what had happened was with all the gyrations, the support broke off. So anyway, that's not very interesting to you, but since it was a painful moment in my life, I wanted to share with you on how that worked. You can also print fun things. This is a toy that, a puzzle actually, that I printed. I print several of these things. They are all very fun to play with. There's different types of printing materials, and this one, this is called a benchy. I got into the hobby for almost 3 years without ever printing a benchy. But when I got my new printer, I wanted to test it on this flexible material. This is a material called TPU, which is a polyurethane model. And it's very flexible. I don't know, you're probably not seeing this very clearly, but it has a lot of give. And I use those, first time I printed a cell phone holder for it, but I use it now to be able to print the little rubber feet for my enclosure project. So I print them out and I have as many that I need for that. So it's pretty cool. Let's see. Here's something that is directly amateur radio oriented. This is a mount for a tape measure Yagi. This is, they're very, very easy to print. They're designed to go into a PVC pipe mast, and then underneath there, the tape measure comes over there. And then there's a cap that goes on top of that. And it even has the mental note, don't print in white if I'm going to show it. There's actually the place where either side of the dipole attaches and your coax. So I am interested in printing up a couple more of these antennas for Foxhunt, which I hope that we'll have at the summer picnic.
Hey, Ralph, I got a question.
Mm-hmm.
It's Joe, W9JCS. So this is kind of timely because, I work at a stereo shop in McHenry here, and we have the need to make parts for old turntables, but you can't order them anymore. So if I have a broken part and I can kind of put it back together to make it whole, how do I get that part to a file?
Now, what is the nature of the part? Is it
breaks is the certain dual turntables and certain techniques turntables. They have these little auto return mechanisms, and it's usually like a little trigger that goes on the arm itself to push either a relay or a micro switch or something to get the arm to start the cycle to retract. So these parts are usually small, maybe a little bit bigger than the size of a quarter, maybe narrower. They can usually go onto the arm, so they might be knurled to fit over the arm like a cam. And then they just trigger something. So they need to be relatively strong. So that was my second question. What kind of plastics can you print with?
Good question. Actually, there are a number of plastics that I would consider to say hobby grade or maybe a slightly, well, it's not commercial grade, but a hobby grade printer. And with that, you can print a number of plastics. One, as I mentioned to you earlier, is PLA, which is what I use most of the time around here because it's so easy to work with and I don't need any special vapor venting or anything along those lines. You can also use PETG. That's a filament that you probably see like in plastic water bottles, but on steroids. You can print ABS. That one you definitely need ventilation, and a number of other materials, including composite carbon with that. But each of these filaments and materials bring their own strengths and weaknesses. For example, ABS is good for UV protection. It tends to be brittle. PLA is not too bad. Its probably weakness is in strength. Although when I say strength, I mean, I can squeeze this very, very hard. I could probably break this off if I wanted to. So, it all depends. And that was, I was asking you about the two things you got to talk about is the type of project that you're building, how it's oriented on the printer. So if you're printing this way, with the lines, this is going to be a lot stronger than if you printed vertically, just because of the layers, because everything is built up in layers. So I don't have a real short answer for that, but I can point you to some directions on it. The other thing is heat. There's because you melt the plastic to form this, you do have a certain sensitivity to heat. So if you are sitting in a car with a direct sunlight, you might notice a slight warping on things in there. That has not been a problem for me. I've avoided that, but I have built some custom brackets in PLA and had sprayed a UV coating on it, and they have been outdoors supporting various projects of mine for probably like 2 or 3 years now. So yeah. So anyway, that answers the second question. Your first question is, how do you get to a model? You may find someone that has already done it, which is or something similar to that. Failing that, then you would model it yourself, and modeling it is basically laying out a series of primitives and shapes and extrusions and things like this. And a program like Fusion 360 or 360 is an excellent tool for that. It has a steep learning curve on it, though, I'm afraid. But I know we have some members that use that quite successfully for doing things like that.
Is there a camera-based program that you can lay the item out and it goes over a grid or something? And I've seen it happen, but I've never actually watched anybody do it.
Yeah, they do have 3D scanning, and I think that, and I don't have experience with that, so I can't speak with definitively on that. But I would think that for some applications, it may be okay. The thing is that if you have a solid part, like what, oh, I'm not showing the screen here. If I have a solid part, and there might be some aspects of this that scanner is not going to be able to pick up. So it's kind of, you've almost got to look on a case by case basis there. So.
All right, thank you.
Mm-hmm. All right. Well, I think that I covered everything. Well, I didn't cover everything, but I want to cover everything I want to kind of talk to you about tonight. The print beds on these printers are, I don't want to say limited, but there's a finite size for that. And another thing is, if you're not familiar with metrics, this would be a good time to employ the knowledge that we learned as children in school, saying that the metric system is coming right around the corner, because most of the time we're talking in metrics. So it helps. And actually, this really shows the strength of metrics, because it gives you an idea of multiples of 10. But here's an example of a camera here, of a TV antenna. This is basically a UHF over the air, and that would have been too big for my print bed, but that was actually printed in multiple pieces. And I've seen people print entire cosplay costumes, like Iron Man or that entirely out of 3D printing. Weighs a heck of a lot of weight. They're able to do it. Okay, finally, before I turn over for questions, I'm gonna start something up here. Let me see. I think I can do this one, I think. Or I actually have some in the printer. Hold on a moment. And I launch my Octoprint, which is a browser-based program. And it's really nice, which I'm afraid I can't show you without keeping you on a few more minutes. But if anyone's interested, maybe we can do another Zoom sometime, and we're not keeping everybody captive. But Octoprint is a really nice program because it gives you a view of your printer. I mentioned there's a camera in the on my printer. It's not, you can take time-lapse photography for that, which gives you a sense of accomplishment because you're sitting there for 10 hours. You can, in a matter of 30 seconds, you see the whole thing build. But the reason that I have the camera in this one is to detect when things go awry on my print. For example, with my poor little Groot here. If I had this camera going at that time, it could detect that I was starting to be generating spaghetti, and it would stop the print. But there's a whole lot of different things that it can do here as far as controlling the printer both locally and remotely. So if you're out at the summer picnic and you want to see how your print's going, you can do that. So what I'm going to do is find something that I'll start the print, and then I can answer any questions that people might have, and at least you'll get to see how this works. Got about 3,000 different things in here. Let's see. Oh, let's start the power pole. Yeah, we'll do that. Okay. I'm going to go ahead, and what I've done is I have this model. I took that program called a slicer, and that controls all of the parameters and breaking that model up into layers that will be printed. And then the slicer is able to go and transfer my file over to the Raspberry Pi, and now the Raspberry Pi will go ahead and print that. So I am going to start that. And this is going to take a few minutes because the bed needs to heat up to the set temperature. By the way, this prints, the hot end that melts there is about, let me see, what is that running at? About 185 to 200 Celsius.
Hey, Ralph, do you want to show us the camera or the picture of the model?
Yeah, I'm going to show you the, well, I did show, oh, I see, you're seeing the model, right? And you want to see the camera. Yes, this is what happens when I have one modulus. Let me go to the printer. There we go. And let's take this in. I'm going to just zoom in here just a little bit, give you a little better picture of stuff in here. So what's happening right now is that the bed, which is this section over here, is beginning to heat. And the hot end, what they call the hot end, that's where the filament, which is coming down here, that's what's going to be pushing down. That is heating up the temperature. And once it does that, then the printer will go through a calibration phase, which makes sure that, because there's imperfections in the flatness of the bed, it's not perfectly flat. The printer will scan that in a matrix, and then it will automatically adjust for any little deviations from the ideal. So that's a really important. The biggest thing, if you get a 3D printer, you need to know how to be sure that things are flat like that. I'm going to check the status of where we're at here. Okay, we're at 215 degrees Celsius on the hot end, which is where we want to be. I'm coming up to 60 degrees Celsius on the bed, which means that things are going to start kicking away here in just a moment or two. And like I said, what's going to happen is it's going to perform a reset to home in the XYZ axis. There we go. And then you'll see it probe. There's 1, 2, there'll be 9 of these. And this is measuring the height of the plate at that particular point. Okay, and then once that's happened, it's going to print down a little bit of a line so that the filament is oozing. I should actually print this in color, more colorful filament. And now it's beginning to go ahead and draw out the model that we were looking at here. I wonder if I can zoom in a little better. Sometimes it's kind of hard to see what is printing here. And this is why time lapse is such a wonderful thing if you're going to be doing a demonstration. Let's see if this helps. Yeah, not really. What it's doing now is it's laying out the 2 circles of the power pole connector, the one that I showed you earlier. And now you're seeing it going back and forth. That is laying down the base layer, the very first layer in there. So it's kind of like filling in the spaces between the model. And actually, if I was able to actually show you, I'm gonna take a risk here and see if I can get my browser working here, and then you'll actually be able to see that.
Tom, here, can you tip the camera down a little bit?
Doubtful. I could try. I could do that, but Peoria may go dark. I don't know. That's probably not real helpful. But you can actually see.
That's good. Very good. Very good.
Yeah, you could see that circle in here now. And so this takes time. This is we're not going to be hanging around here for this whole time, because this right now the estimated complete time is 10:43. So obviously we're not going to be doing that. But I would like to see if I can share my browser. That would be really nice. Let's see. Let's try this. Window capture. Oh, wrong window. Trouble is the settings don't stick. This is Windows and not more or less anything else here. So I don't think this is what I'm looking for. Nope. Back to that. But as you can see, I think the object on the right is the nut, and the object on the left is the actual piece that holds the power pole connectors. Okay, I'm going to slip off here just a second. Really thought this was going to fit. Oh, this looks good. All right. All right, you should be seeing that now, I hope. This is a view of Octopi or Octoprint. It's running on my Raspberry Pi, and you can actually see. Maybe I'll get a better picture here for you here, right here. Oops, that's silly boy. I have to actually click on this. There we go. So this is a close-up of the camera that's looking under at the bed, and in the center there is the hot end where the filament is being extruded. And again, this doesn't make for great television, but I can detect if later on in the process something has gone wrong. Now, there's other ways we can look at this. We can look at the movement of the head, and this is a bit of a lag because it's all being done in software, but you can actually see how things are moving there as things go along. So it is pretty amazing, and I'll tell you, it is magic when you get a complex model, you know, a case or whatever you're printing, and then go to bed, and the next morning it's sitting there on your printer already finished there. It's amazing. Well, since I'm sharing this, I'm going to actually be able to share this Thingiverse. This is the site I told you about, and it has all kinds of different models for free that you can download. These are user contributed. Most of them print without flaw, not all, but most. And the nice thing about a lot of these slicing software, it'll actually detect the error and correct them if they're correctable. Let me see. Here's one, a pie hat enclosure. I can click on that. And this shows what that is. It's like a DMR. And then over here, we can actually look at the files that you can download. And these are the different pieces. And each of these pieces, the STL files, are components of the model that you can print. So it's a lot of fun. The reason I printed a lot of my little puzzles and things like this is I didn't search for amateur radio or something I was looking for. I hit their front page. Oh, that actually is an interesting. I forgot about this. This device over here is kind of a handy thing for me. What it is a USB sort of it's a piece of plastic that fits into a USB A socket. And these are DuPont connectors in there that we use like for test clips. So I printed this out, and this one literally takes like 5 minutes. And then I was able to glue these in. And then if I need to be able to get a quick source of 5 volts, I can just plug it in. So that was actually a good waste of time there to find this. But I mean, literally there are thousands upon thousands and thousands of free models. And if you want to go into the paid realm there too, there's a lot of different things. So since I'm sharing the screen, I could probably go to Thingiverse. Yes, there are Tinkercad. This is this program I was telling you about where I can actually customize things in existing models, so or create new ones. Again, it's not nearly as powerful as a program like Fusion 360 or some of the other ones out there, but it is something that it's free and you can actually play around with it and have a lot of fun noodling around with things. They teach it in school for younger kids to work with here. So there's the model. Whoops, let me just do that. But as you can see over on the right, you have different primitives, different shapes. So I can grab a cube and I can plop it down here, and then I can assign a size to it. As you see, this is in 3 dimensions. There we go. And then if I want to put a hole in it, I can select the cylinder over here and reduce that size a tad bit. I don't want to make it quite that big. And right there. And then I can copy that on top of the cube that I just placed down there. And then let's select them and do this. That's not actually doing what I wanted to do. If I take this cylinder and I can overlay it, and then that's how you cut holes and things. So it's a little bit of a learning curve, but I actually I was able to this is one of my first projects I did with the speaker case by making it larger. I basically took my basic model and then I just took a rectangle and I butted it up against there, and then I made 4 of these cylinders and put them where I want them to go, and now I have a new device there. So here we are. All right, let me switch back to live time here. I'm glad that worked. I don't know why that did not come up there before. I wonder if my SCAD is in here. That works, I do that. And then with that, we can call it a night. Some questions and answers there. Let me see, where did that go? That's Persia, there it comes. Okay. Now my trick is, can I share this or can I get the screen to come up? And I think I can. Back in a sec here. Yeah, this is great. The tool that I use if I'm building chassis or enclosures or anything custom like those desk plates is a program called OpenSCAD. And as a computer programmer, it's more natural for me to describe things as a piece of code as opposed to laying it out visually. That's my problem, but that's the way it is here. Let's see how, where did that go? Okay, let's try this. That. And add a display capture. No, not display capture. Window capture. And let's see, where's OpenSCAD? Try this. Go for the grand slam. Look at that. Okay, fantastic. Okay, had all this work in there before, but you know, that was earlier in the day, but we're back to gold now. This is a free program, and again, it's a little, you know, as like Tinkercad kind of gives you an idea of what it looks like to work with something visually. A program like Fusion 360, which is also free for hobbyists, is much more full featured, and you could do some absolutely wonderful things. Some of these gaming toys that I showed you, the puzzles, were modeled in Fusion 3D. But for me, I was looking to be able to print enclosures. So I created a library, a little computer functions that would actually do lay out particular components, you know, like an SO239, or in this case, here's you can't see what I'm doing here, a volume control. And in the software here, you'll see there is on line 16, I hope you can see that. There's something that says display, and then there is the coordinates and its size. And that will go ahead and create the knockout for the LCD. We also have an encoder, which is the rotary encoder, which is to the left of the display. And then we have 3 jacks that are underneath. So you can kind of describe that, and I can literally lay out something on a piece of paper, or actually measure on the panel where I want it, and it will go there. And that is just, to me, is just absolutely amazing. And then I can actually, let's say, I'll move this one. I'll move one of those jacks slightly off to one side, probably to the left. We'll see. And I'll go ahead and change that. Now it's actually rebuilding that model up again and rendering it. It should be, oh, I got a high quality render. Anyway, that doesn't matter. It'll be done in a second. And once I'm satisfied with how I want it to appear, I don't know if you noticed it there, but that one control that was over to the left of it's very farthest left of the display was moved over there. So you can actually position things, and they're very precise. I mean, I lay these things out. I will go and, like, say, download a mechanical drawing of a particular part or component, and I can go ahead and just enter those numbers in here, as well as their locations, and it is dead on. And I print it, and everything works, you know, just the way that I want. And then once I do that, I can just go ahead and take that and export this file into a file that I can then load into the slicing program and print. So let's see, how are we progressing here?
Ralph, what is the name of this program?
This is OpenSCAD, OpenSCAD. And pretty popular. And again, for computer programmers, like, oh yeah, this makes so much sense.
Yeah, I can see definitely for doing boxes and stuff that's repetitive, it makes it.
Exactly. I have a library of not only components, but also kind of standard types of things, like the snap-on boxes, where you can print a top and a bottom and a snap on. You can print posts that either you can go ahead and have them. Actually, you could even print the threads in there. That I don't normally do because it's just easier to to make that. But this is my go-to program for whenever I need to do enclosures or things where I need to customize things a little bit. Let me see. Go back to. Where's my slides? Where I went here. There we are. All right. So right now we are sitting at 22 minutes. No, that's not right. 17 minutes and 54 seconds into the print build. We have an hour and 30 left. So obviously we're not going to be hanging on there that long. Everything is nominal on that. Go back in and here's the temperature of the this top end. This is the hot end. This is the piece where the filament is pushed through and is melted, and the blue line there is the temperature of the bed. And as you can see, it holds pretty close, and it works out pretty well there. Let's see, control terminal. The guide. Where is it? Oh, right here. This is kind of a nice plug-in. One of the persons in the community had developed it, and I asked him if it could be extended to use some of the wireless connectors that I have. So he and I worked on that and got everything rolling. But this is actually the TP-Link Smart Plug plug-in, or the device, and this is what I can use to actually turn on and off the printer remotely. And when the print is finished, it shuts itself down. And it's kind of nice because it has a power usage guide in there, so you can actually see how much power you're using, and then it accumulates over time, so you can actually see how much electricity you're using, which isn't terribly bad on that. So there we are. So I think that's all that I have. As you can see, things are progressing. This is good. They're not. We have no spaghetti, which is another good thing. I've only had that happen to me once or twice, so it's not too bad. And so what happened is, can we see anything yet here? Okay, you can actually see on the left-hand side there. You can see where somewhat where the yeah, this works. Where the notches for the power pole, I think this is a single power pole, are being printed, and then on the right is the nut, and it is actually printing the threads. Well, it's printing the threads on both the nut and the connector itself, which is pretty nifty. So with that, I know it has been a long evening for everybody, but I thank you for listening, and I hope that this has been somewhat helpful, and probably convince you that you probably don't need one of these, but maybe you do, and it's fun. I print a lot of gifts with them. There's something called a lithophane, and that is where you can take a picture, a photograph, and then render it in 3D. And what I mean by that is that it's still flat, but instead of there's little raises and bumps in the print, and what that does is it tends to pass and block light in such a way that when you shine a light through it, magically it goes from a piece of, let's say, white plastic to a photograph in there, and those are really popular. I enjoy printing those, and a lot of Christmas ornaments or Christmas theme type of things. I printed a TARDIS and a Dalek and K9 for my daughter for Christmas. My son asked me to print headphone holders for him. So, you'll probably be finding things to print more that are not strictly amateur radio related. But they're a lot of fun. And the nice thing is, if you ever need something, you have the ability to make something. I lost a cap for the one of my spider poles, and I was not happy about that, but then I thought, wait a second, I just print one. So I did. It was pretty nice. I don't know if you noticed that or not. Let's see, watch it again here in just a little bit. You saw maybe a little shimmying of the table, which is actually a weighted plate in there, and that is what I was talking about, where it kind of shook loose the model from the support on my poor boot that didn't finish. Kind of like natural resonance on it. And if you look there carefully, you'll see quite often where the bed will, or the head will move up a little bit and move down. Each layer is, this one is set up to be 0.2 millimeters. And the nozzle that I'm using has a diameter of 0.4 millimeters. There's another pass where we're actually filling in material. There we go. It's starting to shimmer now. And I think that's what did me in on that other model. So, all right. I want to thank you for that, and I will let that finish, since you don't want to let a good print go to waste. And I think that's all that I have.
Hey, Ralph, Glenn, Canine OK. I have a couple of questions for you.
Absolutely.
First, thanks for doing this. I actually think 3D printing is pretty fascinating, especially the parts with the power pole holders and stuff. I could see a lot of uses for that.
A lot cheaper too, once you factor the cost of the printer on.
Right. First, I'd like to make a comment. I did see, I kind of been in the back of my head looking at 3D printers a little bit. And I was up at Oshkosh at the air show this year, and there was a company up there that was promoting their ability to print engine parts. They were actually making engine parts, and the way they were doing it was kind of unique, because they were printing, so it would be finely ground, either steel or aluminum, and they would mix it with wax. And what they would do is they would print this mostly steel with the finely ground particles would be held together with wax. When they were done with that, they would put it into an oven, heat it up, all the metal would melt together into one piece, and they could make these really complex parts with, with the 3D printer like that. So,
yep. You can do miraculous
like that. Really, really fascinating. So
there's oh, you're welcome. Yeah, there's actually a location not too far from here that does some very high-end 3D printing, not only of engine parts and full-size scale of, let's say, prototype automobiles and things like that, and of course that is beyond the type of things that we do here, because like you said, they use that metal and things like that. You could print metal, carbon fiber. I can actually print carbon fiber on this printer, and other things like that. You can even print sugar. I don't know why, but it melts, so I guess you can try it. But it's amazing. It really is. And concrete now too.
I guess you could make some really neat cakes with the sugar.
You can, yeah. Somebody, it's like, what was it, that series on the blender, Will It Blend? So it's, oh, I don't know, can I 3D print with a sugar? Oh gosh, yes I can. It was a little brittle though, but it worked.
I just thought that process, because I'd seen it done where it's basically a MIG welder where it welds metal parts, but I'd never seen them print with wax and metal and then go through a second process of putting it in a furnace to actually turn it into a single piece of metal. Other questions that I have, I knew about Thingiverse, and you hit on it a little bit, but how difficult is it to print a custom bracket? Say I want to make a mobile bracket for my mobile radio in my truck. I want to make a bracket to hold the head. How difficult is it to program and create that custom piece?
Well, that one sounds like it might not be too difficult if you're talking about a bracket where there's, basically like a U shape or maybe some variation of that. And that is actually pretty easy to do. You can even do that in Tinkercad. basically you lay out you lay out the shape in 2 dimensions. You draw the shape out, and then what you do is you tell it to extrude, which brings, adds the height to that. And I made, although this was a trivial thing, I did something like that for a audio mixer stand. It was something that was, I wanted to stand where I could mount the audio mixer at a 45 degree, and my students for a 45 degree angle. And it was the same thing. I think I did that in OpenSCAD. So it's something like that is really, really straightforward. Simple basic shapes are not difficult to achieve. Yeah, we can definitely do that.
And one program that I use a lot is Onshape. It's probably one level more difficult than Tinkercad, but it's like an old version of SolidWorks, and it gives you a lot of flexibility for all the dimensioning and grabbing each side of each device as you're building it up, as think of it as Play-Doh, and creating it as a face to draw your next feature on it to either cut away or add to it. So yeah. It's not quite as complicated as Fusion 360, but it's a step above where Tinkercad is. And I think it's, after you go through a quick session of learning how to use it, it's fairly easy to build on it quickly to get some idea to go, if your mind thinks on adding pieces of Play-Doh together.
Right.
So creating simple brackets is not that difficult.
No.
Yeah. No, not at all. Not at all.
Okay, a couple other questions I had. Can you, while you're printing, can you stop and start a print? Say if you have a situation where you have it turns into spaghetti, like you said, can you stop and restart back where it was good? And if you, the other part of this question would be, let's say, I don't have any good examples. Can you create half of a part, install something in it, and then finish the print around that piece that you put in, say a connector or something?
Yeah, absolutely. In fact, to answer your first question, if I was printing, if I was printing this coffee container and I needed to stop it or something disastrous happened, there's a fairly good chance that you'll be able to recover that. Basically, it's going to stop, and then what you do is you go back into that slicing program that I showed you, and then you move that shape up and down until so let's say the bottom half printed properly, and then you start at the top that did not print. And then you could either print that as a separate piece, which is probably the most straightforward. That is the straightforward most way of doing it there, to be able to do it that way. So you can recover that. Now I've had situations where I was about to run out of filament. And this printer's got a filament out detector. And I had one where I was biting my fingernails. Am I going to have enough filament to go? Well, you can actually pause that. And then what will happen is that the printer will lift it up and then move out of the way and allow you to change the filament. In fact, that's what I do when I print things like this, or size. This is 2-color, and that's actually a single model. And then what happens is when I get up to the last 2 layers, the last 0.4 millimeters, the last 2 layers, I tell it to stop, and then it lifts the print head out and away, and then I eject the filament and I put the other color filament in, and then resume. So, if you can anticipate disaster or that you're going to run out of things, it's pretty good. If you get spaghetti, probably your best bet is to, as I said before, take the bottom part of the model, like I had here, and figure out where that is, and then there's the full model, and then on the table in the slicer, what you do is you push this down so that the bottom is really under the table. Anything that's not on the table won't be printed, and so you're going to then print from there on up, and then you can glue the 2 pieces together with some caveats on it. But generally speaking, that's how that works.
Okay, you kind of answered one of my other questions about color changing right there. My last question would be, do you have machine recommendations? I hear the name Creality thrown around a lot. Any machine recommendations or program recommendations or anything like that?
Well, I will also, after I answer this, there may be other 3D printing people here. I'm not sure, but I started out with a Creality, and I ended up getting an Ender 3, which is what they had at the time, and that was sort of the printer, the most popular low end printer with decent quality, and I got a lot of use out of it. I will tell you one thing. That you need to, first off, the thing about 3D printing is that you're gonna need to maintain it a little bit. And I know you would have no problem. When I say maintain, there'll be adjustments that have to be made, parts wear out, cleaning, and this is true from an inexpensive printer all the way to a high-end printer. A printer that works perfectly out of the box, you're going to need to have to do maintenance on and tuning it. With the Creality, because it was a low-end model, there were two things. I got a good one, but they've had some quality control problems in assembly. I think that's mostly behind them now, but be prepared to have to do a little tinkering. Mine worked really well, and then you start adding upgrades, right? Oh, I need a better mounting stand. I need a better this or better than that, and which is fine because I learned a lot about how that printer worked. But at the end of the day, I still ended up less than by buying this Prusa. It was still cheaper to upgrade it, and I learned a lot. So that's kind of a long and short of an answer. You're mechanically inclined, so they're not difficult. I assembled it. Okay, so that should give you an idea that it isn't difficult, but there is, I think the biggest complaint in the 3D community where, it's so popular now, everybody hears about it, they will go out and they'll buy one for their 8-year-old, or they'll even buy them just for themselves, expecting that they could take it out of the box, plug it in, and have it work. The ability to make it work has to do with how well you are being able to assemble it mechanically, because it's all mechanics, right? I mean, you're talking tolerances that are very, very small, and if you get a little bit of if your frame isn't quite square, it makes a difference. But having said that, on a printer now that you can buy for under $100, you really can't go wrong. Just expect that you want to probably put some upgrades into it after you get the feel for what it can do.
So you really like that Prusa that you have now?
Oh yeah, I'm getting old. And what do they say? Life is too short for QRP. Actually, I am doing a lot of QRP now. And I did. I bumped for that. Mike, KD2RP, or what is it, K2MRP, had a Prusa, and we were comparing. We were having different face plates that we are being desk plates we had in there, and I was really happy with the finish in there. But I will tell you, the Ender actually is able to print very good as well in there. But this one actually, I assembled it, plugged it in, and the major pieces were calibrated, and I was printing out. So if you want something that is probably the closest thing to perfection at this price range, that's probably a good printer to get. I definitely would recommend it.
I had the Prusa as well, and definitely agree that it's. I would say if you want to know how it works and want it to live, get the kit so that you learn how to put it together, so that you know how to do the maintenance, know how to do the adjustments. You get a better feel for how it's functioning. It's not hard to do, and they give you gummy bears or
they do,
to steps as you're putting through. So it's a fun learning experience, and it helps. But I think if you want something that is going to be reliable, getting something at like a Prusa level, that when it comes out, it's going to be good. I think, like Ralph said, the other ones, they can be good. It just may take a lot more tweaking to get them to that point. And if you want to pay more, there's companies out there you can spend a lot more than Prusa. But the other thing that's nice is Prusa is open source. So a lot of like Creality and all these other ones, they're using the Prusa open source hardware for software to generate their their system, so they're kind of second sourcing it. And then a lot of times Prusa will give you upgrades. So like mine started off as a Mark III, and then I bought the 3S upgrade. Now I just bought the 3S Plus upgrade that I haven't completely installed, but it allows you to print a lot of your own pieces to upgrade if there's new features that may make things better. So.
Yeah, I don't think you would go wrong with a Prusa. You know, the other thing too, with Creality and really all of the, you know, there's a number of printers that play in that, you know, in that space, is that you can get a good one. And I was very fortunate. I got a good one. My bed, the printing bed was pretty flat. It wasn't warped or anything like that. But the thing is that, you know, you order, if you, let's say you want to buy another one, the next one you'll get, you may find completely different components in there because they source with what they have in there. Prusa is meticulous on the quality of the parts. They have the bearings. And the thing that finally wanted me to go there is I really like the fact that this printer has got, let's see if I can do this here. Has two over here on the left, you see the stepper motor. This is what drives the bed up and down. And by the way, these are all high quality bearings. The Prusa, this particular model of Prusa, has two steppers on either side, which means that it tends to be more stable. Now, my Creality only has one, and every now and then I'd have to watch out because the right hand side would sag a little, but it wasn't terribly bad. But yeah, that's what I really like. I was just impressed, and the support is very good. It's made in the Czech Republic, and they really care about their product. And but again, you know, you'll be spending what is it, $795 I think for the kit, versus under, you know, $100 or whatever for that. So there is a big difference. So I kind of think that just like my amateur radio, the Creality was my Yaesu, which was, well, actually I think the Yaesu is pretty good radio. And then my forever printer was the Prusa or the Flex. You know, I mean, it's basically the same kind of thing with that. Now I see that the print is coming into better focus there. So.
And the other thing I think I really like about Prusa is their slicer software that they keep upgrading. It makes it really easy, and there's a lot of built-in features. Like when you're talking about color changes, you can just click on it and tell it to stop to do color changes at certain levels by dragging up and down. Or you do the same thing. My son made a completely flexible snake, rattlesnake, that the tail took pieces of the clipped off filament that was wasted, and you fill into the tail, and then as it continues to print, that it covers it up, and now you have a rattlesnake because all those pieces are embedded. Exactly what I think you were talking about earlier, how to stop and put stuff in. So it makes life easier than trying to go into the code, figuring out where that is, adding a break, or doing something that some of the lower end ones don't necessarily have the software up to that level.
Yeah, I was using another slicer, which is really popular too, called Cura, for a long time. And then just before I actually purchased Prusa, I did the Prusa slicer, and I thought, oh, this is nice. you know, it works really well. And then the newest version that they just released in there, actually, if you have something like a nameplate, you know, where, you know, like, well, this is not a good example because it's but basically where you have a let's say a rectangle or any shape, and then you have raised letters on it. When you load that model in there to go and slice it, you go, you know, this looks like it's a logo. Would you like me to put the color change in for you? And so it even takes one more step away from things. But, and by the way, you can use the Prusa slicer with any 3D printer, you know, Creality or anything like that. So
nice. That brings me to kind of another question that you guys just touched on. Say like you get a file from Thingiverse or something, that same file works on any brand of printer?
Yes, yes, I would think that that's generally true. The file you'll get is it's got an extension of an STL, and that's basically a series, a mesh, a series of triangles, and that's a standard file format, and they can be loaded into a slicer like Prusa or Cura or anything like that. And then what you want to do is you want to then each of the printers has a profile. There's some things that are uniquely unique to that particular printer. And but yeah, generally you could take the same model and print that in any
So
FDM
it's not
printer.
like an iPhone and an Android thing, the same file, the same app will run on both of them.
Yeah, no, that's true. No, it does work there. I don't, Dan, do you? I don't have a resin printer. Would that be true for resin as well?
Yeah, it still uses a slicer for the STL. Same thing. You can almost think of, the Apple Android. It both opens up the website, and the website is the key that has it. So the STL is that 3D model. The slicer is what breaks it down into layer by layer that the 3D printer is looking at. And if it has something unique that's specific to it and it has its own software, it's going to slice it to make those changes.
Yeah, I was thinking, yeah, the Prusa definitely does that, because that's when I load the model in, I select my printer. One of the printers is a resin model, a resin printer, and yeah, it'll work for that as well. Resin is a whole nother interesting story about how it works, because it prints up and it's a chemical resin, chemical solution, and as the device is printed, or as a layer is printed, it's exposed to a UV. It's UV light. Generally, it's light sensitive, and then it goes ahead and solidifies it. Pretty much, and then it comes back out. So what you're looking at is sort of like your model rising from a bath of resin upside down. But the reason I'm not really, and for people that like to build models, like miniatures and things like that, that's the way to go. But even after you take it out of there, then you've got to go ahead and cure it so that it's permanent. You don't want it mushy. But the fumes, and you got to wear gloves, and it's just for me, it's not my cup of tea for the stuff that I do. So when this finishes up, then what happens is the printer will shut off, and then this is it's a flexible plate. So what I would do then is I will just lift up that plate and then give it a slight, let it cool down a little bit, and give it a little slight twist, and then the print will just come right on off. And you look at the bottom of it, and it's so smooth. It's just amazing. Most of these. You have to look really, if you look at a 3D print, you can tell it's a 3D print because you'll see the layer lines, because again, this is all built up by hundreds and hundreds of different layers in there. And usually they're pretty good. This one you would never know because it feels smooth to the touch, but that's one of the artifacts of 3D printing.
Yeah,
Very good presentation tonight, Ralph. Thank you very much.
Oh, great. I'm glad. Hope it was interesting. I had a lot of moving parts here, and actually literally moving parts.
It looks like it's if you're a builder, you make building things homebrew. This is the way to go, and you make your own custom packages and boxes and stuff that make it look professional. So it's a whole new area for hams to get into, to expand the amateur hobby.
Yeah, and if you mess up, you see what your errors are, and it's just like a piece of wood. You just make your adjustments and do it again.
Yep. And a lot of it you can model. You can actually put it in the slicer and actually see pretty close to how it's going to work. How it's going to turn out. That helps a lot. Sometimes what we have is, as I mentioned before, they have supports so that if you have something called an overhang, like a curve like this, the there has to be a supporting structure that comes up underneath it. But then again, that's another thing that the slicer can generate for you automatically. And if you use the trick with the Prusa slicer with switching to the resin printer, turning on tree supports, and then going back to the FDM, you can actually get tree supports in there. And tree supports are kind of interesting because it literally is like a tree. So instead of printing things solid up here, you know, if you can imagine like pillars that come up to touch the part that kind of hangs, it's almost like supporting structures. A tree literally is little smaller parts and it kind of branches out into that, and it's pretty fun to use in there. So also printed a portable dipole, a portable antenna, basically for a dipole or a fan dipole, and then it has a mount for the Torrid in it, and you know, it's just really handy for stuff like that. If you're really handy mechanically, or even if you're not, like myself.
So how much does it cost to print, material wise? You know, like the object, the USB, or not the USB, but the power pole thing you're printing right now. About how much is it, you know, for the material?
Yeah, I was just checking that. It's relatively inexpensive. I don't have the power pole one there because I don't have it in a slicer. But this case that I was doing for the buck boost converter says that it takes. Why did they say inches? That's amazing here. The estimated cost on there is 44 cents. Basically,
Hey, Ralph, is that polyethylene or polypropylene?
Actually, this is PLA. Something acetone. Polyethylene, that would be the PEG, which would be my second favorite filament to use. It has some interesting characteristics. By the way, another thing too, I found out, this is really fascinating. When I got the printer, I only had one roll of filament, and that was great. They last a long time, actually. It lasts, and the cost has gone up a little bit, but like this is a 1 kilogram roll of hatch box, and the going price might be a little higher now, but it's about $22 for this, and this is enough for a lot of material. And when you slice it, like this box that I'm using here, it says that I'm using 17 grams of material to print that out of 1 kilogram in that. But the thing I found out is I started with one roll of filament, and that was fine. But then I bought another roll of filament, and it's like rabbits. You get two of them together, and pretty soon you got a whole wall of filaments. I got 27 rolls of different types and colors and stuff like that. So be warned about that. I have to print more gifts for that stuff, but it's fun. It really is. But yeah, this is PLA. Right.
And I just learned something too when you were talking about using the other printer to redo it to make the tree structure, because I absolutely hate supports because they're a pain in the butt, but that method sounds like it'd be much easier to take off.
It works pretty good. I before that, well, Cura has got this is that other slicer, has a really good support system. I think it has a lot of other. It's pretty good. I mean, it's a very good slicer, but it has its quirks. Prusa I much prefer, but like you say, those solid supports are a pain. And if you can imagine, this is a bit of an exaggeration, but if let's say we were printing a solid surface up here, and you have to print these supports. You have to print these supports here. And solid, they stick like the dickens to your model, and then you have to really peel them off, and then usually it leaves a little roughage in there, and sometimes it doesn't matter, but then you have to sand them. With tree supports, they're like little microscopic nibs that you can actually sand off, or even just take a like a butane lighter and just go across it in there. So, but yeah, that does work in the slicer.
Ralph, do you need all those colors to build the synthetic woman, or can you do it with less colors?
You got to, the more colors you got, the better. You can't go wrong. And not only is it colors, well, we have the different materials, right? So you have all of those, and then you have got colors, and then you've got things called silks, which are kind of a shiny basis in here. So here's a red and red and green, and this is a red and green silk. And I can't probably tell very much, but it has a really nice shine to it. This is made by a company where they source and make their own filaments all in the United States. Hatchbox is imported from China, but this one is all made in the US. And it's really pretty interesting. This is their filament brand is called Jessie, so, and it was named after the owner's dog. So what I've done is every time I get one of their filaments that is a little bit different, I print out one of his, so I can actually look at it to decide what I want to print for the color. But there's like gold, copper. Let's see what I have in here.
Yeah, that's what Ralph. So this my son. Flip it up the right way. So my son did this for me for Christmas, completely designed it on his own. It's a little stand to hold a heart that he sewed.
Oh, cool, with rainbow filament.
Same thing. It's a rainbow of that shimmery filament. So
yeah,
comes out and changes. You get rainbow throughout your object if you want to create something crazy. So.
That is great. Yeah, I filled up a lot of, as I was mentioning, those lithophanes, and I made a cube of them so that you can have 1, 2, 3, 4, 5 of them there. And then I made it so that you can actually take the lithophane as a piece of plastic, or it's a piece of 3D printed object. And then I made it up so that they can actually switch them. And then I printed that up, not using the rainbow, but a similar gold silk on it. And it looked really nice. This is not quite as nice, but this is a Dalek. That's a gold. I think that's a Hatchbox gold silk. So anyway, as you can see, this could get addicting. So you have to be very careful and stick to amateur radio projects only. All right.
Well, thanks, Ralph. That was really interesting presentation. I learned a lot.
Oh, great. Glad, and I thank you all for attending tonight. And it's wonderful. And if anybody has any questions, you can obviously follow up with me on the reflector or on the radio or things like that. And again, I am not the guru of 3D printing. I will not rat out certain people that I know that are very skillful in the ways of the fusion of the that would make me pale in comparison. There is no comparison for that, but I think that's probably something that I'm going to do someday to learn, because again, with fusion, you could do things. I don't know if this is coming up. You can see the narrows in there. Maybe you can't. Yeah, maybe you see that on the edge here. And I have a design that's pretty similar to that, but it can't do the narrows. And these are just lots of fun to play with. You sit there and they're kind of like fidget toys in there. You have to get all the colors lined up. And anyway, I digress.
Did you print the marbles?
No, I did not. I could have, but problem number one is I'd have to have support, and that means that it wouldn't be round. And actually, the dimensions were problematic in there, but it was a little cheaper just to buy them. All right. Next month we've got antenna construction, and then I think that. We need to line up a program for that. And I'm thinking also, I don't know how much interest this would be in there, but of actually having an evening, or maybe we'll do this at the picnic or something like this, of a showcase of different QRP radios that people have, and show, because what can be done with, pretty inexpensive piece of radio there. So we'll have to see. Whatever the members are find interesting in there. That we'll do. I have the CW Morse Tutor actually is pretty nice. I don't think we had. I'm trying to names a blank for me right here now, but I was working with somebody here. He's a club member, and he built that, and we were having a lot of fun with that in there for drilling on Morse code and learning how to send and stuff. So sky's the limit.
You're gonna have to bring that toy so we can play with it sometime, Ralph. That looks like fun. With
Which
the
one?
marbles there.
Oh, the marbles. Yeah. Well, the thing is that, it's immensely satisfying actually. You just kind of, I showed one to my daughter. Oh, that's nice. And she starts twisting it. And, how do you do this? I got to get all the colors to line up, and and she's playing around. I'll bring that to the next time we meet. We have an in-person meeting just for people to actually see with hands-on of what's printing out in there, and have a lot of fun.
All right. Good night, Ralph.
All right. Good night, Mike. Thanks again for getting the site, and thank you, Dennis, and everyone that came here this evening.
Give it a whirl and see what this process will do.
73s.
73, everyone. Good night.
And I was thinking,
Night.